Hello dear student, myself Kanchan Vishramji Kumbalkar, Assistant Professor, Department of Chemistry of Sri Shivaji College of Arts, Commerce and Science Akola. I welcome you all and congratulate to being a part of such an eminent institute. I am here to deliver a lecture on non-aqueous solvents, which is a part of 4th unit of inorganic chemistry paper. So let's start with the non-aqueous solvent. This is the first lecture. This is the about one part of 4th unit, that is non-aqueous solvents and its syllabus. It is related with the inorganic solutes, inorganic solvents, solvent system concept, the role of solvents in chemical reactions, effect of physical and chemical properties, inorganic reactions in the following non-aqueous solvents like dinitrogen dioxide, anhydrous sulfuric acid, bromine trifluoride, reaction in molten salt, ionic liquids and supercritical CO2 as a solvent. So let's start the first topic, that is classification of solvent. So in this lecture we will going to discuss about the classification of solvents. Now what is meant by solvent? A solvent is defined as a substance which has the power of dissolving another substance. Water is an eluent solvent. What is the meaning of eluent? Eluent is a carrier compound in which the another element has been get dissolved. So the solvent, it is nothing but a substance which has the power of dissolving another substance. On account of its high dielectric constant, before moving the further point, we have to discuss about what is meant by dielectric constant. Dielectric constant means it is a power of any solvent to apart the ions. For example, we have a NaCl. If we dissolve a NaCl in water, the water have a capacity to separate out the Na positive and the Cl negative. And this capacity or this power is nothing but depend on the dielectric constant. If it is high, then it is known as the high dielectric constant. If it is low, then it is considered as the low dielectric constant. The high dielectric constant solvent is considered as the good quality of solvent. The best or the highest dielectric constant is of water, and hence water is considered as the best solvent. There are some other reasons also on the behalf of which the solvent can be water as a solvent is the best one. So let's check out. On account of its high dielectric constant, that is about 72 to 78 dielectric constant of water has been observed, it is capable of reducing forces of electrostatic attraction binding the charges ions in electrolytes in the solid state. Means, in simple way, if you are putting a NaCl crystal in water, water have a capacity to separate out the Na positive and Cl negative. There is an electrostatic force of attraction between the Na positive and Cl negative, and because of the addition of that NaCl in water, the NaCl gets separated out by means of Cl negative. So this is because of the high dielectric constant. Thus salts and other electrolytes get dissociated into ions when they dissolve in water, and the solution conduct electricity. Water has, we know that what is the basic reason behind conducting electricity? If any water content having the ions, if it is having a positive and negative ions, then and then only the electricity can be conducted from that particular solution. So high dielectric constant, conductivity of electricity of that solution is because of the water have a capacity to separate out the positive ion from that of the negative ion. Water has a long liquid range, that is 0 degree Celsius to 100 degree Celsius. This means that water exists in a liquid phase in between a 0 degree Celsius to the 100 degree Celsius. Means some liquid are not that much range of liquid considered. So hence water is considered, this is the third point on the behalf of which the water is considered as the best solvent. And hence because of it is a 0 to 100 degree Celsius, hence is a liquid at ordinary temperature. It is most easily available and can be easily purified. It is available, that's why we spoil it easily, which is a very bad thing, but okay. It is most easily available and can be easily purified. It is neutral, it is odorless, it is non-toxic, non-poisonous, and it can therefore be handled with safety. For example, if you are using a acetone, acetone is having about a nice quality as a solvent, but because of it is somewhat hazardous as compared to the water, we cannot use thoroughly. Next one, it is having a explosive property also, but water doesn't. Hence, during direct heating on a burner, you can use a water freely, but you cannot use ethanol, methanol or acetone on a direct heating as a solvent. So these are the some advantages of water as a solvent. Due to all these characteristics, water serves as the most useful solvent. There is an attempt have been made to find out some other common substances also which could serve as a good solvent like water. Means it is not possible to identify a exact good quality of water as a solvent, but there are some attempts has been done and could also have sizable dielectric constant. The highest dielectric constant is of that of the water, and hence about equal dielectric constant can be considered, so that they could have a high ionization capacity. So remember one thing, if you are considering the high dielectric constant means what? The ionic compound gets separate out into ions and they kept apart from each other, the positive ion and negative ion, and the capacity to make these ions apart from each other in a high way, that is considered as that of the high dielectric constant. If any solvent having low dielectric constant, it separated out, but the ions cannot apart from each other at particular that level. So by considering this, there is some attempts has been considered. So on the behalf of this, the liquid ammonia, liquid sulfur dioxide, anhydrous hydrogen fluoride, anhydrous sulfuric acid and liquid dinitrogen tetroxide are some solvents. Such solvents has been identified, which are not exactly like a water, a good quality, all these qualities are not found in there, but some amount of qualities has been identified here. Now the next important point is that the classification of solvents. The various solvents are generally classified as follows. The first, that is a protic solvent and aprotic solvent, depend on the proton. The compound or the solvent which consists a proton and which can be after dissociation give a proton, then that is known as the protic solvent. And for example, H2O, NH3 and HF. In this, the H positive ions can be get identified. The H positive is nothing but a proton, and hence such type of solvent is known as the protonic solvent. The solvent in which the proton exists, that is known as the protonic solvent, or simply the hydrogen, which can be the presence of hydrogen after dissociation. If it is giving H positive, then it is considered as the protonic solvent. Second one, a aprotonic solvent. The solvent which does not exist the H positive ion, that is proton, is known as the aprotic solvent. For example, CCl4, carbon tetrachloride, and the benzene and acetonitrile, etc. In this, we know that CCl4 there is no existence of H. In C6H6, because of it is a aromatic compound, it is not possible to remove a H positive, and hence that can be considered as that of the aprotic solvent, because there is a existence of hydrogen but which cannot separate out the proton, that is H positive ion. Hence solvent from which the proton cannot be ordinarily derived are called aprotic solvents. So examples are CCl4 and C6H6, etc. Next one, the acid solvents, basic solvents and amphiprotic solvent. We know that there are different three types of solutions can be considered: acidic, basic and amphiprotic. Acidic means which is having a pH less than 7, or which is considering, there are basic different three definitions of acids on the behalf of which the solution can be considered as the declared as a acidic solution. Second one is the basic solution, or basic, we are dealing with it here the solvents, but basic compound means which can be considered as a basic on the basis of various three different definitions, that is Laurie Bronsted, Arrhenius and the Lewis concept, on the behalf of which accept hydrogen, and there are three definitions on the behalf of which the acid solvents, basic solvents and the amphiprotic solvent. The amphiprotic solvents are those which neither have a strong tendency to gain or neither have a strong tendency to lose a proton. So it is having the both the character, that is acidic as well as the basic, that is known as the amphiprotic. Now focus on the solvents. The solvents which having a acidic character means what? The solvents which have a strong tendency to give protons are called acid solvents. For example, liquid hydrogen fluoride, then sulfuric acid. We know that sulfuric acid, acetic acid, HNO3, etc. These chemicals are easy to donate a H positive, hence they are acidic, and if you are using this compound as a solvent, then it is considered as the acidic solvent. Next one, the basic solvent. The solvent which have a strong affinity for the protons are called basic solvent. For example, liquid ammonia. We know that ammonia is a basic in nature. If we are taking a liquid ammonia is not eligible to accept a proton, hence it is known as the liquid ammonia. Next, hence it is known as the basic in nature. So liquid ammonia is a basic in nature because it is eligible to accept a proton by easy. So next example is the pyridine, next one is the hydrazine, and so on. And the last one is the amphiprotic solvents. Amphiprotic solvents who's having the both the characters, that is acidic as well as the basic. But the amphiprotic solvent can be defined as those which neither have a strong tendency to gain or nor a strong tendency to lose protons. For example, water, methyl alcohol, ethyl alcohol, etc. We know that water is a amphiprotic in nature. It can be act acidic as well as basic, depend on it is with the acid. If it is water is with acid, then it is behaves as a base. If water is with base, then it is act as a acid. So with respect to the other element which is present with the solvent, they act as a appropriately acid, and bases depend on the another compound which is present with them. So such type of solvents are considered as the amphiprotic in nature. Next one is the ionizing and non-ionizing solvents. Ionizing solvents are those which are capable of undergoing auto or self-ionization. Self-ionization and auto-ionization means what? The species which gives the different two types of ions, one is the cation and another is the anion, and this is the self process. There is no requirement of any external force. So by simple method they exist in a two ionic form, cationic as well as anionic. For example, water. In this there are three examples has been shown. First one is the water, second one is the ammonia, and third one is the sulfur dioxide. Now water, if we take a 2 moles of water, then it split up into 1 mole of H3O positive ion and another is the OH negative ion. A cation has been formed and another is the anion has been formed. So the neutral species get converted into the two different ionic species, and such type of formation of ions is known as the ionization, and this is used as a solvent, hence it is known as the ionizing solvent. So the solvents which are eligible to give auto ionization or self ionization, they are considered as a ionizing solvents. Next, another example is the NH3. NH3 get converted into the NH4 positive with a NH2 negative, anion and cation. And lastly SO2. SO2 again get converted into the SO2 positive and SO3 2 negative. So this is all about the autoionization and ionizing solvents. And the solvent which do not ionize at all are called as the non-ionizing solvent. So basically there are various different types of solvents. So if it is ionized, then it is known as the ionizing solvent. Ionization means what? A neutral species get converted into one cation and another is the anion, that is known as the ionization. If it is self-derived, then it is known as the self-ionization or auto-ionization. If the ionization is not possible in a solvent, then it is counted as a non-ionizing solvents. So ionizing solvents have high dielectric constant and are polar, obviously. Because of there is a formation of positivity and negativity, means we can clear it that there is a formation of poles. Poles means what? The positive is not like a negative and negative is different from that of the positive. So that can be considered as, when we are considering ionizing solvent, it have a high dielectric constant with that of the polarization, that is there is a formation of poles. Non-ionizing solvents, obviously there is no formation of positive or negative ions, so there is no polarity, there is a non-polar character has been developed. So in a non-ionizing solvent which is having a low dielectric constant as well as they are non-polar in nature. So in this lecture we are dealing with the protic, aprotic solvent. Protic solvent means which give a H positive, that is known as the protic solvent. The solvent which does not give H positive, that is known as the aprotic solvent. Second, on the basis of nature, acidic, basic and amphoprotic solvents can be considered. Acidic means which generate H positive after dissociation. Second one, which accept H positive like NH3, that is known as the basic solvents. And amphiprotic solvent means which is not interested strongly to accept or donate H positive ion, that is considered as the amphiprotic solvent. And the last one is considered as that of the ionizing and non-ionizing. The solvents which are gives a self or auto ionization and generate a cation and anion, then that can be considered as the ionizing solvent. And the solvent which are not give such type of reaction, then it is known as the non-ionizing solvent. The ionizing solvent have a character that it is having a high dielectric constant and it is polar in nature, but when we are considering the non-ionizing, they having a low dielectric constant with a non-polarity, there is no generation of poles. And at the last, the water quality. Water as a good solvent. Water is the best solvent because of some reasons, because of it is odorless, chemically non-reactive, it is easy to handle, it is easily available, it's having a very high dielectric constant as compared to the other solvents. That's why, and it gives a better ionization, and that's why the water is considered as the easily available cheap solvent, and hence it is considered as the best solvent for the purpose. various purposes. So this is all about the first lecture. In next lecture we will start with the characteristics property of the solvent. So up till then, take care, be safe. Thank you very much.